When we're talking about energy, it's useful to have a couple of sorting categories. We're going to have two top-level ones, and then we're going to have lots of subtypes. Now, our first top-level one is going to be kinetic energy, and that's associated with motion. So anytime something is moving, it's got kinetic energy. That's true at the large scale, but it's also still true at the small scale, and that's going to be something that's important and not always intuitive. Now, thermal energy is an example of that. This is when we get down to the microscale, and it's going to be a form of kinetic energy. Now, we say thermal, and we immediately think temperature and heat and things like that. And that's the right way to be thinking, but it's not really thermal energy the way that you're thinking of it from outside of chemistry experience. When you shrink down to the microscale, it's all about how fast your individual molecules are moving and banging and colliding into each other. That's really what we're talking about when we talk about thermal energy. It's all about energy of motion and collision. Kinetic energy. Now our other category is going to be potential energy, and this is something that's associated with position, or something that the object contains. Also, when we get to the small scale, that's going to be because of position too. We'll see that as we're talking about lots of different examples throughout chemistry. Now, just to get those really concrete in our mind, potential energy, that's a weight elevated above the floor. You let go of it, it converts that potential energy, energy of position, into kinetic energy when it suddenly falls out of the tree and comes crashing down. It's moved from something that was less stable to something that's more stable when it went from high to low. And that's going to be common for the types of energy that we're going to see.